Hi, everyone. I'm sorry for the delay, but I hope everyone is here and attending. Let's welcome Cristina, Pedro, and Filipe. They will be presenting themselves, and if it's not the first time that you've been to our data webinars, I'm sure you know their faces. However, if it's the first time that you're here, I will start by presenting myself. I'm Raquel. I'm the community manager of Ironhack Lisbon, which is a global tech school. We have bootcamps around the globe, around 9 campuses actually, in Europe and America, and 3 types of bootcamps at the moment. So web development, UX by design, and of course, data analytics. If this is the first time that you're dealing with data, this is a good start. If you're already starting your data journey and you want to learn more and maybe even take a course on it, you can ask in the end, or even ask a question, any questions about the bootcamps. I'll be very happy to answer. So before we start, let me just tell you a bit of the rules that we have here. Hope everyone can hear it. And you can see that we have a chat here. Some people have been already chatting a little. I'd love to know where you're from. If you're anywhere from Portugal or any other country in the world, I'd love to know. But other than that, other to chat, we have another good thing for you to ask any questions during this webinar, which is ask a question. Yes, you see here below the videos. You can ask all your questions there or leave a topic that you want to discuss. And Cristina and Pedro will make sure to answer. Or during the webinar, once they're teaching, Filipe will be answering all your technical questions because, as I said, you can code along within this webinar. So you will be able to ask your questions. Amsterdam, cool, Mexico City. So don't forget to ask your questions on Ask a Question. It will be much easier for us to answer. Please leave them there. And if you see any question that you want to see answered that's already there, you can upvote it. I will be sharing a few links here on Ask a Question. You can please upvote it so it appears on top because I think they can be useful for you. For instance, we'll be having more webinars next week. I'll be sharing here. I'd love to know how you're using your time wisely. So I'll be sharing here a link for you to share. And we have a Slack channel for you to keep practicing. So maybe after this, all the attendees that are here can keep practicing together, and we'll be sharing other resources. Anything else? We have a call to action here. Access your data here. It's a green button below the videos. Christina and Pedro, they will be explaining a bit more what this is about. But basically, it's for you to keep up with the exercises that will be working and that will be managed here, so you can access that. I hope you had installed what I sent you earlier, because that will be important for the webinar. Other than that, I think we're good. I'll pass the word now to Cristina and Pedro and Filipe. We'll introduce a bit yourselves.
Okay. Hello, everyone. My name is Cristina. I am Italian, as you can hear probably from the accent. I am a biomedical and software engineer, and I usually work on computer vision and biomedical signal processing. And also I teach data analytics in Lisbon. We are all from, as Raquel said, we are all from the Lisbon campus. This is part of the teaching team. That's it, I guess, from me.
Hello, everybody. Good to see you all. I see some names that I already recognize from other webinars. So for those who don't know, my name is Pedro. I'm Portuguese, and I am currently the lead teacher of the part-time data course at Ironhack Lisbon. I also teach a course at Católica University of Business and Economics. I don't know if any of my students are from Católica are there. If you are, well done. If you're not, I hope you're studying. So that's I don't care. Okay, so today we have a pretty cool workshop ahead, but first of all, let's have Filipe introduce himself as well.
Hello, guys. I'm Filipe. I was part of the data analytics cohort in October 2019. Now I'm working as a teacher assistant for the part-time, and I'll be answering your questions in the Q&A. So go ahead and leave them there.
Okay, cool. I hope everyone heard. Anyway, I will leave this webinar now to the hands of the experts, so to speak. You will be seeing maybe Christine and Pedro's face, but Philippe's face will not be here. However, as he said, he will be answering all your questions on Ask Questions. I can't stress this enough. Please make them on Ask a Question so it's easier for us to answer. But if anything, you can still chat in the chat. And I'll be seeing you, or you'll be seeing me in very while. Okay? I will leave it now to Christina and Pedro.
Thank you, Raquel. So can I share this already? No. Here we go. Okay. Can anybody see my screen? I think there's a small lag between me talking and between you guys hearing. Yes. Okay. Cool. Okay. So great. Again, we're very happy to be here, and thank you all for being here with us. So today the workshop is about a gentle introduction to machine learning. Okay. And so without further ado, let's get to it. Let's see if I can change this. So we had the introductions. I think Christina, I guess, already introduced herself. So I think I'll skip this slide then. Myself as well, I already introduced myself. In case any of you want to talk to me a bit, you can always send me an email to pedro.carneiro@ironhack.com or on LinkedIn, etc. And so without further ado, what's on the menu today? So today, the first part is going to be me talking, but don't worry, it won't be very long. I'm going to give you a bit the introduction to the main machine learning concepts, okay? So it's going to be a very gentle introduction, but then it will fully allow you to make the most out of the second part, where we have a no-code demo using Orange software, where Christina will show you how we can use machine learning to predict the effectiveness of a Facebook post. So I won't go into any more detail on that. Okay, let's go. So before talking about machine learning, I actually want to tell you a bit about what's a decision. Because in the end of the day, with machine learning, what we want to do is we want to make a decision. We want to make a prediction. There are many types of predictions, but this is the main idea, okay? And so on a day-to-day basis, we all, we are faced with decisions, right? And in every decision, so what is a decision? Basically, it's a point in our minds, right, where we have to decide based on some factors if we go one way or we go another way, or multiple ways, But the point is that there's no straightforward path, okay? For example, right here, this decision tree here to the left, where I see, am I really hungry? Well, I evaluate if I'm hungry. If I'm hungry, I'm going to eat something. If I'm not hungry, I'm not going to eat something. Very simple, right? It's a very simple decision tree. I don't know if you guys are hungry. I'm okay, but so I'm not going to eat anything. Well, a bit more complex decision tree is what appears to be the decision tree of my cat. So my cat, great cat, but apparently whenever I want to give him something, he thinks, is that for me? If I say yes, then he doesn't really care about me and doesn't want it, okay? If I say no, and it's not for you, I'm sorry, that's my dinner, then in fact, he really wants whatever I cannot give him. So these are examples of decision trees. And so first of all, to understand what machine learning is all about, we need to understand that there are several types of decisions that need to be made based on data, based on criteria, okay? Like here, for example, my cat, okay? He has to ask a question before being able to make his decision, okay? And that decision will then have a consequence, okay? And in machine learning, this is very similar. So what's the big difference? But before that, let's see another decision tree, a bit more complex. So should I attend the webinar? First of all, is it organized by Ironhack? If so, then. If not, then maybe, it depends. If so, that's a pretty good indication that it's a good webinar. However, am I speaking the webinar? If yes, then maybe I'm not going to go there anymore, right? If no, then perfect. It's a great webinar. Let's go for it. The point here that I want to make is that you see this decision tree over here. It's actually an example of something a bit more broad called an algorithm, okay? And so an algorithm is a sequence of steps, of logical steps, where we execute certain actions. And here we have an algorithm based on decisions. So again, this is an example of an algorithm that I made up when I was preparing this, of course. And now let's go to the core of what is machine learning. The thing is, machine learning is very similar to this in that the objective is to make a prediction based on the value, many values, many variables, okay? However, the big difference is that the tree that I presented before, the decision tree, is learned by the machine, okay? It's all, what are the questions that we should be asking? What are the variables that we should be considering, okay? That process is decided by the computer based on all the information available and also based on historical data points, so on the past. And so the point that I really want to make is that it's the machine that learns the algorithm, okay? It's not the developer that says, if this, then that. It's not me who decided to make an arbitrary decision tree, okay? It is the computer that, based on some criteria, okay, of trying to, optimize a problem, it could be decreasing an error, it could be many things, okay? But based on some criteria, we will have the computer create its own algorithm based on the data, okay? So this is like a very gentle introduction to what machine learning is. Before going into more technical side, let's just see some examples that you might be familiar with. So a very common use case, which is an example that we actually, a project we did in my previous job at the bank, was speech recognition. So imagine that we want to translate the content of what I'm saying right now to you guys into text, okay? So we can have, a text reference of the webinar, for example, that we could read. So this process of converting voice conversations and the way I'm saying things into a textual record is actually a subset of a problem in machine learning, okay? And so it's something that could be done. Furthermore, there are many teams in companies that what they do, they are somehow related to client support. And so they're receiving many, many emails with client requests. And you can take care of these emails by order, right? First come, first serve, for example. Or you can use machine learning to, based on the content of the email, to infer the importance of each email, okay? So this, again, would be an example of a real application of machine learning. Again, we had a similar project like this in BNP Paribas where I used to work. Finally, not finally, but we still have very broad area of machine learning, which is what I call client segmentation recommendation. And so whenever we're on YouTube and we want to see the next YouTube video that's recommended to us, this was recommended to us based on our previous experiences. And so as a client of YouTube, I am being segmented and the recommendation is being done to me, okay? And finally, this is another example that's very dear to me, which is fraud detection. And I don't know if you know, but there's a very interesting Portuguese company already that is growing a lot. And their business model is simply based around a machine learning algorithm to identify if a certain payment or transaction is fraudulent or not, okay? So this again, just for you guys to see how as a tiny application in machine learning became a company, a whole company in itself, The point here is that just to try to make you guys see some real examples before going into the concepts. Without further ado, let's go into the concepts. So in machine learning, there are two types of problems, let's say. They are supervised machine learning problems and unsupervised machine learning problems. And so basically, this is very important for us to understand, okay? Whenever we have a defined output that we want to predict, okay, so is a payment fraudulent or not, okay? What's the level of importance of an email? Is it critical, medium, low, okay? These are examples of machine learning, of problems where we have a defined output that we want to predict, and looking at past data, we have examples, okay? This is called a supervised machine learning problem, okay? Whereas, on the other hand, if we don't have, a fixed prediction that we want to make, we just have data and we want to somehow infer correlations and infer similarities, this is called an unsupervised machine learning problem. And so these are concepts. Let's see some examples, which I think are pretty self-explanatory. Okay, I think hopefully we all know these cartoons. Okay, at least I do from my childhood. So let's imagine that we have the following cartoons. Okay, some of them are are from Disney. Some of them are not. And we look at them here, and we see, okay, let's have an algorithm that, based on these data points, which are these cartoons, okay, they're going to try to classify them in a similar way, okay? So based on the similarities. So here we passed, here are in the middle, our unsupervised learning box, okay? And the box realized that, okay, these three kind of belong in the same similarity group, in the same cluster, we say. And these two over here, well, they're a bit different. But, like, what was the criteria that the algorithm used to do this? Was it Looney Tunes versus Disney? Well, no, because here we have Donald Duck, but then we also have this duck from Looney Tunes, right? So that was not the criteria. Well, and even though these two, one is from Disney, one's from Looney Tunes, they're also one group together. So maybe, the algorithm recognized that here there were some similarities in the legs or in the beaks, and that down here we didn't find those similarities. But the very important point that I was trying to make here is that since we didn't give it any target variable to predict, an unsupervised machine learning algorithm, all it can do, and it's already very valuable, is to cluster the data points into groups of similarities, okay? This is very important. If you remember this example over here, I can boldly say that you kind of understand the concept behind unsupervised learning, and then of course it's a matter of studying the algorithms, understanding what's behind the hood, okay? But I really think that if you can explain this, you're already pretty good, okay? Furthermore, so of course, I love Looney Tunes. I see here the comment from João, me too. Now, supervised, back to supervised learning. In supervised learning, it's different. Let's imagine we want to have a problem where we want to classify if a certain data point is a cat or a dog, okay? Or in fact, a cat or a non-cat, as in this example here. What do we need? We need to have a data set, okay? In this case here, we only have cats, but it has to have both cats and dogs, such that then we can train our model, okay? So what will our model do? Our model will look at a bunch of cats and dogs. It will see for each case, what are the common variables that make something a cat or make something a dog, okay? And then we train the model, okay? Once we have the model trained, we have like this box that's perfectly tuned, perfectly calibrated to receive a new animal, a new pet, and classify if it's a cat or a dog. And this is what we do here, okay? The main crucial point here is that in a supervised machine learning problem, we already know the label or the variable which we're trying to classify. In this case, cats or non-cats, okay? So these are, let's say, at the higher level of machine learning, the two main categories. There are then a few others, but we need not to go into them here today. Furthermore, within supervised machine learning problems, we also have two subclasses, okay? We have two different types of problems. The first one, so these are either regression or classification. So in a regression problem, the value that we're trying to predict is a number, okay? It's a continuous, it's a number which belongs to a continuous range of values. For example, a regression problem could be trying to predict what's going to be the temperature tomorrow, okay? It can be 30 degrees, probably not, right? It can be around 22 degrees here in Lisbon, I would say. I don't know. But it can be 22.1, 22.2. We never know, okay? It's continuous. So this would be an example of a regression problem. On the other hand, if we want to turn this problem into a classification problem, the key difference is that the output is no longer a continuous variable, but it's a categorical variable. What does this mean? It means that it can only take one of certain values. In this case, we could turn this into a classification problem if we wanted to predict if tomorrow it's going to be cold or hot, okay? You see how we turned a problem which had a continuous scale of temperatures into what we call a binary classification problem, where there's either hot or cold, okay? So hopefully you understand that these two categories are subcategories within the supervised learning problems. So now that we're here, today I'm gonna give you a small example. Okay, I'm gonna quickly go through it because then the real example is gonna be given by Christina with a hands-on approach. But imagine that we want to predict if a given flight of the low-cost carrier Brian Air, okay, you might have heard of it, if it's gonna be delayed or not. Okay, I don't know what's your experience with this carrier. I did these slides while I was at the airport once, and the flight was delayed. That was my inspiration to do these slides at the time. So we want to predict if a given flight is going to be delayed or not, okay? And so we can take this as a supervised machine learning problem, as we'll see, and we can take this in two ways, either a classification problem, will it be delayed, yes or no, or a regression problem, which is trying to calculate how many minutes before or after the boarding time the flight ends up leaving, okay? And so depending on how we structure the problem, we can either take it as a classification or as a regression problem. Let me change slides. Okay, and so whenever we have these problems in machine learning, we have to think, what information would we find useful to predict a delay? And then our jobs is to go get this information, get this data source, clean it, do all the data manipulation, and then create our model. So I put here some examples. Maybe, the location of the airport is something that's relevant. Maybe the current number of flights that are currently happening in the airport. Of course, it will give you an idea of how packed the airport is right now. Maybe the number of people booked for the flight. Is there a cabin crew strike? So these are all variables which us as humans, we understand very quickly that they are relevant for this problem, right? And I'm going to stop saying the word variables, and I'm going to start saying the correct word, which is features, okay? We have to think of these things as features of our machine learning algorithm, okay? So the features are basically the inputs that we're going to give our algorithm for the machine to learn, to train, okay? And then based on these new features, we'll want to predict a label, okay? We're going to want to predict a target variable. I hope this is clear. If we understand what features are, then we'll quickly understand as well that there are two main types of features, okay? For example, the name of the pilot, the airport location, if there's a cabin crew strike or not, these are categorical features, okay? Whereas on the other hand, if we look at the ones in orange, they are numerical features, okay? The number of people booked in the flight, the average cost of the tickets, the number of flights in the airport, etc., okay? So this is all, this is the main thing that we have to understand about features, okay? They can be these two types. And then if you then will be interested in further studying machine learning algorithms, you see that there are many. There's a whole zoo of them. And our choice will really depend on the types of features that we have and the type of problem that we have, okay? This is something, unfortunately, we don't have time to show you today, but it's something that I want you guys to take away as well. And so we already saw how there can be numerical or categorical, no problem. And now let's look at a small example, okay? I just put here, a data set with a few flights. And then, of course, we have here the information about each flight, okay? So, okay, we have many flights. We have the features with the respective values. And then we have a very important column, which is the label column, which is crucial in a supervised machine learning problem, because we need to know for past data if this flight over here, okay, was delayed or not. Same thing for Porto, same thing for Azores, etc., okay? So this is very important that we understand this. And then, the machine learning algorithm, what it's going to do in a supervised machine learning problem is it's going to look at all these combinations of values and try to, in a way, I'm going to use the word correlate or relate them to the fact that a flight is typically delayed or not, okay? This is what's kind of happening under the hood. Now, of course, these 7 or 8 or 9 rows is not enough for our model. You have probably typically heard that to train machine learning algorithms, we need a lot of data. Why? Because we need a lot of examples, okay, to make a good prediction. And so whenever we have data, we need to split it in the following categories. First of all, we split it into training and test data. So the training data is the data with already labeled, so the past data on which we're going to train our model, okay? Basically, the model needs to look at a lot of previous examples, okay, to be able then to make proper predictions about new things. if you think of it, that's also kind of how we as humans kind of learn as well, right? We learn from past experiences and therefore are able to make future predictions. At least that's one of the learning paths for humans, right? The test data is then the data that we have for which we want to make real predictions for, okay? So we can look at this as the real world data. Well, imagine these are the flights of the future that we want to predict, okay? Finally, the validation data set is the data set which we, from our training data, we take a small slice and we kind of leave it out in the beginning when we're training the model. And then we train the model on the remaining 90%, let's say, and we pass the validation data set through the model that we trained just to see if it works, okay? This is, again, part of the machine learning pipeline that we have to do for a project. Okay, hopefully that was clear. And now just a small summary before we go into the last part of what I'll be talking about, which is how we can evaluate the quality of a machine learning algorithm. But before going there, we learned how there are, in supervised machine learning, there are classification problems to predict if an email is spam or non-spam, for example. There are regression problems where we want to, based on a given feature X, predict the value of, in this case, the price of a property, okay? So this is a numerical one, it's a regression problem. And then finally, we have clustering, which is an example of unsupervised learning, where we don't have any predictions that we want to make, okay? We just want to find clusters of similarities. So I think this slide visually is a nice example, is a nice, let's say, summary for you guys to keep in mind, okay? And so now what we're going to do is we're going to go algorithm, but type of problem by type of problem, and we're going to see how do we evaluate if the machine learning algorithm was good or not. And then Christina will also kind of show you this as well when she does the demo part. So in regression problems, we use something called the R-squared. So the R-squared, for those of you who have studied statistics, you have seen it many times probably, it's basically a measure, okay, without getting too technical, it's a measure of how distant the points, the real points that we have are from the linear regression, in this case, of our predictions, okay? And so it's kind of looking at the variance of our model compared to reality, okay? And the R-squared normally goes from 0 to 1 or 0% to 100%, depends how you define it. I've seen it defined in both ways. And the closer you are to 1, the more you can infer about the quality of your regression in explaining the variance of your models, okay? Again, I would love to talk more about that. We could have a whole class just about the R-squared, but we have no time, unfortunately. Just think of it as a number where we use it to evaluate the quality of our machine learning algorithm. Then, if we go now to classification problems, let's imagine a binary classification problem where we want to predict yes or no, okay? The thing is that our algorithm is going to predict either yes or either no, right? And so then what do we want to do? So our algorithm in, let's say, these 9 predictions over here said yes, no, yes, 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 no, yes, no, yes, okay? And in reality, we then went to check with the real values, okay? And they were yes, yes, no, etc., okay? And what did I color code? I coded that when the algorithm made a correct prediction, I put green, and when the algorithm made a wrong prediction, I put red. And so in this case, it's very simple. I think we've all lived with accuracies all our lives, right? Like the grade of your test is a measure of your accuracy in the test, right? It's a number of correct predictions, in this case, over the number of total predictions, which would be, in this case, I think 6 correct predictions over 9 incorrect predictions, okay? Very good. So this is the most simple metric that we use to evaluate the accuracy of a classification problem. But let's take it up a notch, okay? We can also, let's now imagine a classification problem, okay, where we're trying to classify a variable, okay, we're trying to predict a variable that can take the values of A, B, or C, okay? So our algorithm is going to predict for each row of data either big A, big B, or big C. But then in reality, the result of that data, okay, was either small a, small b, or small c. And the mixture of these two components is called the confusion matrix. Okay, sorry, confusion matrix. I don't think I pronounced that correctly. And so what do we want to do? Well, to fill this in, what do? We have our model, nice and trained. We pass through it a lot of data, and then what happens? The values which we predict as A, and in fact were A, we put them here. And so we start by doing that, okay? We start by filling what's called the true positive values. What are the true positive values? They are the values of A, where we predicted A and it was A, the values where we predicted B and it was B, and the values where we predicted C and it was C. So basically, there are a number of correct predictions, okay? And after doing that in our confusion matrix, we then go in a different way. We go down the column. And so now, there are some values which we predicted as A, but in fact, they were B. So we found 3 instances of this. Or on the other hand, we found 7 values, so rows, data points, where we predicted A. However, the real value was C. And so these are mistakes, right? These are points where our algorithm failed, okay? So this is one angle. And then we can fill this in for all columns. But then we can also look at the rows, okay? Because check out the rows. There can also be, just like we interpret the columns, we can also see examples where we predicted B, but the real value was A, or we predicted C, where the real value was A. And so from this confusion matrix, okay, we can define 2 new metrics that are very important in these problems, called precision and recall. So precision is how precise, redundant, right? But how precise your predictions are, meaning how many times did I correctly predict A out of the total number of A predictions. And so in this case, it's, okay, I predicted A correctly 33 times out of, how many times did I predict A? Well, here, plus here, plus here. So 33 out of 43 times, okay? And so my precision is about 76%. So when do I care about precision? I care about precision when I want to make sure that when I predict A, it is in fact correct, okay? We'll see the importance of this in a minute, okay? So this is precision. On the other hand, there's also recall. And if precision is going down the column, recall is going across the row. So what is recall? Recall is how many times I correctly predict A divided by the total real cases of A. In this case, I correctly predicted A 33 times out of 49 cases where A was there, okay? And so recall is also known as sensitivity. And so as we are, depending on the problem that we want to evaluate, we have to see which one we want to premiate, okay? I see here there's someone saying that they didn't get it. Let me go again, no worries. So basically, I can make 2 types of predictions, okay? I can say that, think from a point of view of A. I can say that I predicted A, okay? So here. Oops, what am I doing? Sorry. I predicted A, when in fact it was B or C. And so I made these mistakes over here, as we can see, 3 and 7. Or, okay, I can look at it from the opposite way. I can say, look, I predicted 33 times A, and the real cases where A was there were 49. Okay, so this is the difference. It's very subtle, I think. It took me some time to understand this, but it makes a complete difference. And I think the best way to see this is through an example. Okay, so if you allow me, we'll come here. Okay, imagine that I want to make a prediction based on an MRI, based on some medical image. Okay, if a given patient has cancer or not. Okay, now we have to think. Do I want to give more weight to precision or to recall? Let's think. If I wanted to premiate precision, then all I cared about is whenever I predict, I'm correct. And there's one very easy way to do this, which would be wrong, but it's easy. Look, imagine that we are 1,000 people, okay? And I'm a doctor, I'm very conservative. I really want to be precise. And so when in doubt, okay, let's say 500 people don't have cancer, and then 400 people I'm kind of in doubt. And so if I'm in doubt, I say, no, they don't have cancer, okay? I might be missing many people who in fact had cancer. But if I only say that those 100 people, which I'm really sure had cancer, I only predict them as having cancer, then my precision is incredible. You see, I didn't take any risks, but I was very precise, okay? But maybe I let many people go home having cancer and thinking that they don't, okay? So in this example, if I wanted to premiate precision, maybe it's not the best example maybe it's not the best use case to do that. Whereas recall, what is recall? Recall is out of the total number of people that in fact had cancer, out of my 1,000 people, I want to get as many of them as possible, even if that implies many times one person comes, I'm in doubt, I say yes, cancer, and then it turns out they didn't have cancer. So in that case, my precision decreases because many times I'm being inaccurate. I'm saying you had cancer, and then the person gets worried, of course, but then in fact, no, you didn't have cancer. And in that case, my precision is getting worse, but my recall is better, because if I, all the people that had cancer, probably I'll catch them, okay? So again, it's a subtle difference. Let me be very extreme, okay? If I were very extreme, I would just say, everybody has cancer, okay? Out of 1,000 people, I say 1,000 people have cancer. For sure, I will catch everybody in that data set that has cancer. My recall will be incredible, 100%. But my precision will be crap, you see? On the other hand, imagine that I'm in a situation where I have very scarce vaccines, okay? And I have to give them out to people who will, the vaccine will solve the disease. What do I want to be sure? Unfortunately, many times there are people who I'm not sure have the disease or not, and so I can't really give them the vaccine because I have so few. What I have to do is, in the cases which I'm sure are ill, I have to give them the vaccine. And so I really want to premiate my precision, okay? So again, I think this is right now the best I can explain it, okay? This took me a few times to understand, okay, myself. In mathematics, or in statistics, this is very much related to type 1 and type 2 errors, but I won't go more into this here, okay? Nevertheless, keep on reading about this. It will make a click, I'm sure, okay? And so, cool, Barbara, I'm happy you got it. Hopefully there are no more questions here, okay? So, now it's time for Christina to take the stage and show you the demo of how to do this properly, okay? So let's go, Christina. You can share. Let me stop sharing my screen, and the stage is yours. Thank you, everybody. I'll see you in a bit. You're muted, Christina. Sorry.
Okay. Can you hear me?
Yes.
Perfect. Okay. Thank you, Pedro. It was very enlightening. Okay, so let's try to use what we saw so far and to apply it to an actual example in real life. Okay, another one, because we first saw the Ryanair. There are many more cases. Let's go and have a look at another one. So first, what we're going to use to have the look to another one. Okay, so this is my screen. Hopefully now you're all looking at it. You're all looking at it? Perfect. Yes, good. Okay, so first, if you click on access your data here, you will be sent to this drive, okay? Now, what's in there? I know it's tons of stuff. Do not fear. So what you actually need is the first four, okay? This and visualization and manipulation, they are the previous webinars. So if you want to go and have a look, feel free. But these are the actual data files that we need tonight, okay? Okay, and we are going to have a look at how we are going to use them. Second thing is that this is actually orange. So as I understand, some of you are having, it's taking a while to install. If you have Anaconda, it should take less. Yes, whoever you said that before, you're right. Do not fear, it will actually get installed. Okay. So what is orange? Orange basically is this whiteboard here, when you can drag and drop these icons, okay? So these are representation of pre-coded blocks. For example, each of them, they do something, okay? So here we see that there is stuff for data, and then there are multiple other things. So for example, there are little icons for visualization, for model. This is all for machine learning, so we're going to use them. Again, for evaluation of the machine learning models, more machine learning models. This is unsupervised, which is clustering. We are going to do one example of it. And then there are so on and so forth. Now, when you install Orange, probably you won't see this. Probably you won't see this one. What you are going to see, sorry guys, is everyone seeing my board? My orange board? Okay. So probably you are not going to see these ones. This is because to get more add-on, you actually have to install them. So you get the basic version, and then depending on what you want to do, you can add more stuff. There is, for example, the image icons, there is bioinformatics, there is tons of stuff. So you can go and browse. For data, you can either import files, or there are some datasets pre-installed. So basically, they are in the system. And when you want one, you can just select it and try. There are many with machine learning. So after this webinar, maybe you want to go and try some other stuff. You don't have to go and look wherever they are here. Okay, so now erasing them is very simple. You just click on delete. And what are we going to do? So each little block, as we said, is basically pre-programmed. In this case, file is the importing command. So what if you double click, it will open up this window, and we are going to select first the regression train. Now, here we can see the famous features, also known as columns. And so features come from machine learning, but data scientists, they juggle between machine learning, where they are features, and SQL, where there are attributes, which is always the columns, and pandas, where maybe they are called characteristics, columns, or attributes and features. So sometimes you just decide on one name for everything, or some other time you try to follow the different things that you're doing and call them differently. Now, these are all the columns that we have in our new data set, and we will arrive to this data set, what it is, in like 5 seconds. These are the types, what it means. Each column, it can be categorical, yes, no, 1, 0, numeric, a number, text. So for example, if you have a data set of all the reviews for your restaurant or whatever, then that would be text. Data time, which would be the actual date and time of something happens, okay? So you can select something different, and when you select something different, the actual column will get all bold. And if you actually want this to work, you have to apply, to click on apply. I definitely don't want this to work. We want to go back here. Another option that you have is role. So if you double click, you can choose this to be a feature. So a feature to be very practical. They are the characteristics of a situation, an event, or something that you're studying that you know beforehand, even when you want to predict the outcome. Okay, the target is what you want at the end of all this, the software to tell you. So, for example, in the Ryanair case, if how much was the delay time, or if there was actually delayed, and so on and so forth. And you can also skip if you don't really care about this column, even though it's in the file, it's not at this moment, you don't care about it. Okay, so perfect. This is all what Orange does, but what's our data set, right? So our data set is this one. There are plenty of data sets around, and Google now also created the research data set option, so it's much more easy to find. This is a data set that I got from UCI, which is a ginormous machine learning repository. Well, this is one of them. And if you want to have, actually, they are used in this in the analysis that this paper is on. What happened? So we are having posts. Sorry, we have posts on Facebook for a specific brand. Okay. So for each post, we're going to have page total likes, the category of the post, which are 3 different categories, the month in which the post was posted, the weekday, so Monday to Sunday, the hour, if it was paid or not for the post, how many comments we had at the end after a while, how many likes, if it was shared, if there were total of interactions in some way, and also if the post had link, photo, status, and video. So if you see here, there is a bunch of zeros and ones. 1 is meant in the Boolean way. 1 is true, and 0 is false. So the link, when it's 0, it means that there was no link in this post. When the photo is 1, for example, in here, there was no link in this post, but there was a picture, there was no status reported, and no video. For example, in here, there was only the video. So what was actually shared in the post? So these are all posts from the same brand. And why is this important for the brand to know? What's important for the brand to know is about the user interaction that the single post provokes. So the more user interaction, the better awareness of the brand, which in return, it gives more revenue, maybe more buyings, whatever it is. Now, from the social media perspective, you just see a post. So what you want to know is what is the actual result in terms of brand awareness, of user interaction, how many clicks that this post has, and if it's actually worth it, okay? So in this case, our target is the user interaction. Now, the target is what we are going to predict. And the features that we use to predict how many users interacting this post had provoked are the page total likes, categories, past months, past weekdays, and so on and so forth. One row is 1 post, okay? So they are already happened, okay? We know all about these posts, okay? And there was a bunch of very knowledgeable people to decide how to verify the user interaction. Okay, so we have what is happening on the Facebook page and what is the actual return of investment, in this case, that is eliciting this specific post or not. Okay. Now, generally speaking, we would like a software that from only the knowledge of what's happening on the social media, so which category is this, which month the post was published, blah, blah, blah. We want to know how much user interaction this provokes. First, we want the regression version. How many users? Then we want to know the classification version. If I have a minimum of the user interaction that is worth for post, in the case of this specific brand, do I hit the target or not? And then we are also going to have a very quick look at post segmentation. Okay, so far, this is the data table. Please confirm. I can't see you very well, so please confirm that everything is good so far. Okay, sounds good. Okay, so now what am I going to do is first, if you want to spend some more time in here, you can also, before doing the machine learning training and prediction and everything, you can also have a look, for example, at the statistic features that we have in here. So you just need to drag and drop the icon and then link it. And you'll get all the statistic features, sorry, all the distribution, the mean, and then minimum, maximum, also how many values are missing, which is very important for us. The color is theoretically is the target. To be honest, this works much better for classification, because if you have just a yes or no version, then you see how many options you have in one kind of the other. But we will arrive there. So far we're doing regression. Now, to do an evaluation and a prediction, so what we actually sell is the prediction, right? That knowing the month of the post, the hour, the weekday in which this is published, blah, 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 we will know, or we will be able to predict up to a certain probability to get it right, that this post will get this specific user interaction. So to do that, we need the data and the model, okay? So the model is here. Now we are doing regression, so we are going to have an example with one of the regression models. There are plenty, and one of the things that machine learning people do is to try more models to see which one would be the best for this specific case. Okay, so now we have the data and the model. What we need to do is to find a way to actually decide how good this model is gonna be. What does it mean? Okay, so let's erase one sec the feature, statistic feature, and let's use a visualization icon. There is the scatter plot. Okay, so this is the scatter plot. In here, we can select one of the features for axis X, one of the features for axis Y, and we can also select a color for the target in this case, and we can select many more features for shape, size, label if you want, and other options. For example, you can get grid lines. If you want, you can get a regression line if you feel it, and so on and so forth. Also opacity, because sometimes when you don't have opacity, you have no idea how many dots are here in the specific spot, which now that I'm hovering, you can see that there is more than one. But if there is no opacity, then the color is the same for the same range. So have less information, let's say. In this case, you can see how many dots one on top of the other there are. So another thing you can do, and once you actually decide on a color, you can find the most informative projections. You need to click here on Start, and then wherever you click, then you will get the actual plot. Now, this is total interactions versus the likes. So of course, there will be more likes per total interaction. Let's go, so you can have a good look at all the possible options. Now let's go and do something else. Let's say, for example, that I want to know if I have comments, how many user interactions I can get. Now, the very good thing here also is that you can zoom in and move around. So let's have a look. Okay. So let's say that I have no comment. Oh, sorry. Let's say that I have no comment. So for no comment, I get a lot of different results for my target, okay? Which are from 0 to more than 40,000. Now, if I had to predict, based on the 0 comments or any other number of comments, if the user interaction would be high or not, or what actual value I need, then this is not really useful, is it? Because, to be honest, there are way more values here. So I'm pretty sure that it could be more probable that the target, the actual value of the target, it will be around here. But still, we're talking from 0 to almost 20,000. And again and again. So if I have, because these are all the data that we already know. So basically, the algorithm will be based on data of things that are already happened, and it will try to predict what will happen in other occasions, which will be later if we are talking about time events. And in this case, we are just talking about posts. So what if instead I have more than 40 comments? So in this case, we have only 2 options. So either we get more data, or we can kind of assume they will be around here, right? But it depends. It depends on the model. But this is to say that, for example, if values are spread around, then it's much more difficult to have a good prediction. Okay. Let's see if I find, okay, here we go. For example, if I have the total likes of the page and I have very few likes, there is no previous value that tells me that the target will be over 20,000. Make sense? So we are going to use a model that more or less very easily interpreted that does this. So what we're going to do is to use the evaluation icon and to link the data and the model. Now, it's telling me, hold on, there is something wrong here. Yes, because it's missing separate test data. What it means? So what I passed so far is the trained data, the data that I use to make my model. So what I need also in some other data to see if my model, the one that I made trained on my data, actually works on other data, not one on which I trained my model on. So what I'm going to do is I'm going to remember that I actually have 2 sets of files each for regression and 2 files for classification. So I'm going to import the other one and I make sure that there is the target, that everything is numeric here. Okay, so I can do, and I also link it here. And now there is no problem anymore. Okay, so let's go and have a look at what we made. So this is the evaluation result. These are all the options that you can have. In this case, we are testing on test data. Please notice that the test data is the second one that you linked. So if you are having some trouble and maybe saying that this is the data, is because you have to link this one last. Okay. Now, for this, we have evaluation results. As Pedro already explained, for regression, one of the options is the R-square. So in this case, it's telling us that 40% of the variability of this data is explained using our features, our model, our previous data. So it's not that much. This is the part in which the machine learning teams, they actually work a lot, because the whole game is to actually have these values to improve. So what they do is, in this case, they get more data, definitely more data, and they try different models. They try to improve every single model. They do something that is called hypertuning, for example, and so on and so forth. In this case, when I emphasize like way more data, what I meant is that here we only have 400 instances, so it's not that much. For a good machine learning model and trained model, you have to think more on the line of 5 digits kind of data. 6 would be better. But in this case, Orange, it takes a while to process everything. You have to think of Orange as a CPU with 1 core. Okay, everything is in online. Otherwise, you have to program Orange to do parallel. So it would take a while to actually process everything. So that's why we reduced the rows to kind of speed up the process. We only have 1 hour. Okay, so far we have test, and we have a trained model, which is here, and we have our test data here, which I'm going to rename so no one gets confused. So this is test, and this is trained. Okay. Okay, so everything is good. Now, what we're going to do is here with the crystal ball, we are going to predict. Now, what do we need to predict? We definitely don't need test and score anymore. We just need a trained data and our model. Sorry, a trained model on our data. Sorry. So we are going to link our model and the data and to bring everything on prediction. And this block already recognized that there is a model and prediction, but it also needs new data. Now I can do 2 things. Either I can try on the data that I already have the result, so I already know the right answer, to see how it goes. Or I can provide new data, and I just have the prediction of how is going, how many user interactions I'm going to get from this post, which I don't know yet. So I'm going to do both things. So first, I'm going to use the test and predict on the test. So what's happening is that this on the right side is my data with the features and everything. And this is the actual value, okay? Now, this is what it was predicted. Now you can see that the prediction is kind of a little bit off. So this is, again, this is one problem for the machine learning team. They need, or person, they need to get these 2 values to be way closer, okay? And you know how much these two values are closer, instead of looking at all the possible results, what you do is to go and look here at this value on these other ones, okay? So in this case, R square is 41%. So we already thought that the predicted result and the actual result, they wouldn't be that similar. But still, we are just trying to understand what are all the stakeholders in this game. So let's do this other thing. So this is still to see if you get it or not. What we are going to do now is what you actually buy. So what you actually buy is that if I have some data, so this is my data. If I have a data, then I don't know how much is the user interaction yet. I click here, and so in this case, I know. So what I do is remove the target, and now I don't know anymore. Now I have a bunch of new data about posts that I do not know how much is the user interaction. So what you're going to do is, this is what actually goes on from the client side. That my model, the trained one, actually gives me the answer. Okay, so it tells me that this post will probably, the one has 135,000 total likes, that belongs to category number 2, that it was posted in September, blah, blah, blah. So let's assume that we are in September and we want to know how it went. That probably it will have 9,000 user interactions. Okay, so this is what's happening on the regression version. Now, let's go and talk about the classification version. So these are all possible values, right? So as Pedro rightly made as example, depending on the case, we can also have decimals. In this case, we don't have decimals because there is no half user interaction, okay? So our regression won't take into account that there are decimals. But the difference is, either this or that, which is the classification, or how much, okay? How much is the temperature today, and how much user interaction there are, and how much delay the Ryanair plane or any other plane can have, and stuff. Now, classification. Tomorrow is going to be hot and cold. Is there going to be a delay or not? And now what we want to know is, for example, if I have a minimum number for which the post is worth for me or not as a brand, and I put this to 500. So instead of knowing the actual count, I can just say yes or no, it's going to be worth or not. And then I won't know how many actual users get to interact. But I will know if it's worth for me, okay? So how do we do this? So first, let's erase most of this stuff. So this we don't need. This we will go back and add again. And here, now we need to import the classification train. And I'm sure you already guessed. Here we need to import the classification test. So that is the data, and I downloaded it exactly from the website that I showed you. To make it more usable for this specific webinar, I also manipulated it. You can, for example, try to use Tableau Prep that we showed last time. And now we are going to use it here to see how the classification goes using Orange. Now, what we have in this case we have the same, exactly the same situation with the same information per post, except in this case, the target is 1 or 0, which in this case, again, is used as a Boolean, like 1, okay, is this post is worth publishing, and no, we could have done better, okay? Room for improvement, oh yes, this was a good one, okay? Now, the scatter plot is slightly different because now we have only 2 colors, which in this case is blue for room for improvement kind of post, and the very good posts, they are in red. So now we just have to determine, based on the features, if our future dot is red or blue. So worth it? Not worth it. Now, let's go and have a look. For example, let's say that my new post gets a total or 1,000 interaction, or let's say it is 600 interactions and 40 comments. So we are more or less around here. Now, sorry, more or less around here. Now, around here, there are all red dots. So what's the probability that, what's the chance that I get a blue dot in the middle of a red bunch? It is pretty low, right? It is more probable that since all the actual posts that have a similar value per feature, they were all good ones, probably our post will be a good one. Same problem. Let's see something else. So here, what if instead I get 60 total interactions and maybe 1 comment? So I'm about here. Now, these are all blue. Now, my future posts that have similar values, probably it will be a blue one, no? Now, obviously, we are doing this with 2 features, but machine learning models can do this with 80, 100 features, okay? So I get it, and now it sounds very easy, and we can do it by ourselves, but one of the points of using machine learning is because it can take into consideration way more features, okay? So let's say that instead we have a total interaction of 120 and we have 1 or 2 comments. So we are about here. In this case, it's more trickier, right? Because there are reds, there are blues. So what do we do? So in this case, we calculate the probability that there is red and that there is blue. And we decide on which one that has the highest probability, okay? Now, let's go and see how to build a model. Obviously, this is how one model is built. So mostly I'm talking about the algorithm of the module that I'm going to show you, which is the KNN. There are different models that are built on different ideas, okay? But the result is always the same. Well, hopefully there will be some models that have better results, but coming up with 1 or 0, that's the whole thing of classification or other options. Okay. So we need the model, we need the data. Again, we still need more data. And we need the evaluation. Now we link everything. And it says, there is no test. And we are saying, no worries, here is the test. Okay, so now for this specific model that we haven't even changed, the test has a precision of 70% and a recall of 70%. If you click on data, it's on the train, it's always higher, okay? But what we really need is not to know how well it did on the data that trained, is how well it does, our model does, on data that is not the one it was trained on. So Now, we saw prediction and recall, and from Pedro's slides, we also saw, here we go, the confusion matrix. So what we're going to see here is the number, here you can see number of instances, proportion of predicted, and proportion of actual. So the number of instances, it means that in the test, there are total 100 posts, okay? 48 of these, they have been predicted as worthwhile, good ones, and 52, room for improvement. And actually, there were 54 actual good ones with user interaction over 5,000, and 46 room for improvement. So the predicted as good one, 36 of the actual good ones. Okay, so it predicted A18 as wrong. Okay, perfect. So if we want to see a proportion of the predicted, we can see that, for example, for the predicted as valuable posts, 75% were actually very good posts. So the whole game here is to turn this and this into a very, very low number, okay? Okay. So we have our team of machine learning scientists, engineers, everything that work on this, on having a better model, having more data, having definitely a better recall and prediction. And we end up with our wonderful model. So what we are going to do is that we are going to predict something. So in this case, we connect the data to our model in this way, and we provide a trained model. And now we do the same thing here. So let's see what happens on a test. So on data that we already know the answer. Okay, so this is our data, and this is the actual answer, and this is the predicted answer. What all these numbers means? On 0 and 1, they are assigned probabilities. Okay, so 100% it was 0. So in this case, it definitely was 0. Here we have a 67% that it was 0 and a 33% that it was 1. So it was chosen the possibility with the highest probability, okay? And this was actually 0. In this case, it was chosen 0, but it was a wrong one. So in this case, this is the case in which the prediction says 0 and the actual is 1. So this is one of the cases in which the prediction says 0 and the actual says 1. So this is one of these 34%. Okay. Perfect. What are we actually selling? Is not something from our data set, but assuming that we have new values, assuming that we have new values, for example, let's fake having new values and just drop in the target column. It's a very well trained orange, he already knows. So in this case, this would be our new posts that we need to understand if they were good or not. And this is the prediction. So for each prediction, we know that there is a probability that this is right. Okay. Okay. So this is what the classification does, and we saw what the regression does. The only thing left to see is this. Are there groups around from all the posts that we have? Can we group them into clusters, also known as groups of posts that have some features in common? Okay. Okay, so for doing this, we are going to use the supervised and the k-means. The k-means is one of the possible models, and basically what it does is to look at the points that are very close and see if they could be from the same group or not, more or less. So the k-mean algorithm works if you tell how many groups you want, but also you can ask, what's the number of groups they will give me the best performance. So we're going to select this, and the performance is measured by what we call the silhouette score. Now, the silhouette score is how much the groups are very well separated and defined. In this case, it's telling us that it will work so much better if you have 2. So we're going to go with the fixed 2. And now the only thing that we need is to go and actually look at what this one looks like, because we can see that what the algorithm actually did is to introduce an additional, there is still a target, sorry, to introduce an additional column with C1 or C2. Basically, if this particular row, so this particular post belongs to cluster number 1 or cluster number 2. Why? Oh, okay. Sorry. Okay, sorry. We don't need the target column, so we are just going to use the data without the target column. And we are going to have another look and see there is the actual silhouette score if you want it, and there is also the cluster. Okay, so let's see what we have. Let's see what we have here from the prediction, and let's see what we have, here from the clustering. So we want to understand what's the difference, more or less. There are plenty of differences, but let's have a look here at the KNN and what's the most informative, for example. And let's choose one that does not have photo per last month. Okay, here we go. So this is a scatter plot of total page likes and the past month. So depending on the month, actually there are more likes. Okay. Now this is from the prediction. Okay, sorry, from the prediction. So this is the clustering. Okay, so we already knew that this specific, well, this is the prediction, but this is if the user interactions, they were over or lower than 5,000. Okay, let's have a look here. So let's have the same, a similar. Okay, so we have page total likes, which is here. Oh, here we go. And past month. Now, we can see that there is a difference between the red and blues. And this is why what they represent is totally different things. So here we have here in the clustering, it's not even taken into consideration. There is no talk of user interaction. It wasn't in the list of features that we passed. So this is telling, like the DAX and Disney versus Looney Tunes, this is telling that these groups, they have things in common, values for the same features in common or similar. This is telling that the red ones belong to the posts that have a specific value on the target column, and the blue ones belong to the post that has specific values on the target column. Okay, so there are still two options, but there are completely different interpretations and also models and data. Okay, for example, this is also used in marketing to do maybe the customer segmentation. in imaging to do segmentation. One of the very famous and now very classic option is to do the k-mean, and so on and so forth. Okay, and I think we did everything we were talking about. So the first one is we did regression, and we predicted a value in thousands of possible values. In this case, we predicted a yes or no option. And in the k-mean, we did not predict anything. We studied the data to see if there were group of posts that has something in common. Okay? Now, I think that this is all done. I'm going to save this, and I'm going to upload it if you guys want to have a look. I'm going to upload it into the folder for with the link that is already here. So you should just finding it later on, okay? And I think, Raquel, I think that we have time for some questions if you guys have some.
Yeah, I think so. We have a bit of time. Thank you, Christine. Thank you, Pedro. It was an amazing webinar. I know maybe if you didn't have time or if you didn't have the opportunity to run through the program, if you didn't have the chance to keep up, or if you want to review it later and try once you have it installed, you can review it. We will make sure to make a follow-up with the webinar. Yes, Arthur, we will. So we will send you the recording so you can review it. So don't worry if you feel like you didn't catch up. But before we go through the Q&A, I just want to remind you all that we will be having more webinars next week, even about data. We have one on Monday. It will be in English, although it's held in Amsterdam, and it's also about machine learning. So a bit of a different approach, not so technical, but it should be good for you to lighten up about this. And of course, you can see here that I put on Ask a Question. We have other webinars, and if you want to learn about our bootcamp, if you want to take your learnings even a step further, you can also learn about that. Also, I would love to see how you're using your time wisely, not only with these webinars, but especially. So if you want to show us how you are, please tag us on Instagram. I left here the link, and we'll make sure to share. And last but not least, if you want to continue to practice these, or maybe if you want to discuss with other attendees the exercise that you've been doing here, maybe some of you are a bit more advanced, some of you have other resources to share, we created a Slack channel just for that. So if you enter there, we'll see that we have several channels for you to discuss things about the webinars. We'll be posting new webinars there, and we'll be sharing new content, not only about these webinars and the contents that we do here, but for you to keep learning during your quarantine. So it'd be great if you sign up, and if you give us some suggestions of what you'd like to see there. And thank you for your feedback. So I will give a bit of the word to Christina and Pedro. If you still, guys, have any questions that haven't been put yet, we still have a bit of time for you to leave them on the chat or ask a question, and Christina and Pedro will be sure to answer them here a bit. And thank you for your feedback, guys.
Okay, so maybe we can have a brief look over the questions that, if you guys don't have additional, that Philippe already very rightly answered. So we can reiterate a few concepts. Because I see there was some confusion about features and columns and everything. So for data scientists, there are like 4 names for columns depending what you're doing. Okay. So in SQL, you will see that there is a webinar, future one, that Pedro will lead, and he will talk about SQL, and he will call them attributes. And now we call them features. And in pandas, maybe we call them characteristics or features again, because honestly, we are still talking about the same thing. And this is because at first, SQL was its own field, and machine learning was kind of its own field, even though it comes from statistics. Well, it's based on some mathematical concepts, and so everything has its own thing. But then we decided to use, for example, SQL to store and briefly manipulate data first, and then machine learning to come up with answers and predictions. And so everything got linked together, and now data scientists, they actually have like 6 names to choose from when they talk about columns. And so you can just, depending on the team, they just have decided names, or they try to be very precise and use the ones always in the same in the specific context, and so on and so forth. So yes, definitely, if you hear them called different things, is totally normal, honestly. And also the algorithm. So when I talk about the model, yes, so there are obviously more than 2 algorithms. There is more than 1 algorithm for regression and more than 1 algorithm for classification. And in the way to explain what was happening, I was using actually part of the algorithm for that I was actually using. So there are other ways to go at it, okay? And usually you should try a little bit more ways to see which one gives the best result, and then try to improve 1, 2 of the best 3 options that you get. And definitely 500 rows. This was an example. So we used very few rows. 500 rows is never going to happen.
Guys, also, if you have any questions about Ironhack itself, if you've been hearing for us about a while and you're still a bit confused, you can also we can also answer your questions about it. Yeah, that's right, Mateus. The link of this recording will be available through this link. However, if you lose it for some reason, we will be doing a follow-up with it, and we will make sure to tell you about the next webinars if you want to attend. So don't worry, you will be getting this recording. And I am pretty sure that if you didn't have the time, or the I don't know, maybe it was a bit of a rush, or you didn't get to install it, I'm sure that you are going to be able to do it at home. Or maybe even learn new concepts within the next webinars, and then everything will be a bit more clear in your head. So are there any more questions from you guys? Because if not, oh, wait, we have something.
No. Like actually, Philippe already solved it, so no worries.
What kind of things Orange can do? This one? Did you see this one, Christina? What kind of things Orange can't do that?
Oh, multiple stuff. Actually, we had a discussion before starting the webinar, Pedro and I, and we were saying that Orange is a little thin of pre-processing the data. And so actually there could be a combination with Tableau Prep and Orange, because Tableau Prep doesn't go very well with machine learning, but is better at pre-processing, selecting rows, and so on and so forth. And Orange has more options as machine learning, text processing, and so on and so forth. Do you agree? Pedro, do you agree?
Yeah. I think so. I think, it's in general, it's always, for those of you who were in the last webinar that we gave about the no code or the low code paradigm, it's always a bit of trade-off as well, in my opinion, between the thing of having code and Python, and in practice, having access to everything, in my opinion, or having a much faster time to development. I hope you guys really appreciate the fact that Christina built those workflows, okay, in 45 minutes, okay? I think this is incredible, whilst explaining to you, okay? On the other hand, if we had to code it, it's a bit more intensive, right? It's more error prone. Nevertheless, it's always a mixture, I think, between speed of development and then full features. But I don't know, that's my opinion.
Cool. I hope it was clear to you, Jose. Okay, cool. Do you guys have any other questions?
So it's a problem there.
Because if so, we can wrap it up. And of course, you are free to reach out if you have any additional questions. Okay, maybe we have some question here for Ray, but I will just keep saying this. If you have any additional question or you want to reach out to some of us, you can do it so on the Slack channel that we created. So we're pretty sure we can answer your questions. Christina and Pedro, do you want to take this question?
Actually, Orange sells soy is an open source. I never paid anything for Orange. I don't know if they start now, but
yeah, and
you're muted?
My knowledge, Orange is free.
No, you're not.
I'm muted?
No, it was a delay on the video.
Okay.
I'm sorry.
Sorry. Yeah. To my
On
knowledge, Orange is free. I don't know if there's an enterprise version.
On the Anaconda
but,
distribution, you can just download it and go with it. It's so
Okay.
no problem.
Guys, just to wrap up, it was great having you here. It's always great to hear feedback and to see that you come from not actually here, but you are from everywhere in the world. And it's amazing to see that you're using your time so wisely at home to learn these new things. And I hope you keep on learning, like to reviewing this and to come to new webinars or learn new things by reading articles, by practicing. I hope you do so. So if you need anything, of course, you can reach out to us. We will be making a follow-up. So if you want to anything, you have our contact there or in the Slack channel. And share your learnings with us on Instagram. We'd love to know. Do you have anything else to say before we go, Christine and Pedro?
Yes, definitely.
Nice
thank you for coming.
Thank you, guys. Bye.
Thank you very much. It was a pleasure.
Bye.